This explains a lot. Because what you like, you do well. And he liked thinking, not just in mathematics.
Let's roll. All right. Hi, everybody. Welcome to Coffee Lit Rev. I'm Chris Hendon, sitting here in Eugene. And today we're going to be discussing a paper published in the journal Food Chemistry in 2021 titled Impacts of Quaker Beans Over Sensory Characteristics and Volatile Composition of Specialty Natural Coffees. I'll give you a brief overview to start. Basically, Quaker beans are the observation that when you roast some coffee, occasionally you're going to find some beans in there that come out much, much lighter than the bulk of the roast. And you'll typically will find that they impart negative flavor characteristics. At present day, Quaker defect in roasted coffee, as defined by the Specialty Coffee Association, the limit for that defect is 0 beans. In other words, coffee is not specialty if it has any Quaker beans in it whatsoever. And obviously, this presents as a challenge because you don't know about this defect really until you've roasted it. And so the impetus of removing them lies on the roaster. Joining me today to discuss the paper is my producer behind the virtual glass, Doran Pennington, and our coffee professional guest to help us dissect this article today is Andrew Tolley. Some of you have probably interacted with him over the years. He has worked at Harrison Houle and Taylor Street Baristas. In more recent times, as serving on the SCA, the Specialty Coffee Association's board of directors, and in 2026 will be the president of the SCA. Welcome, Andrew.
Thank you. Pleasure to be here. I'm also working on the Coffee Knowledge Hub as well, which is an education resource for coffee professionals. So check that out.
Yeah, and they've just got a new podcast that's just come out. So I'd encourage the listeners of this one to go and take a look at that.
Thank you. Thank you for that plug.
Okay, so couple of items here. I'll tell you, a Quaker is a phenomenological observation that some beans come out after roast being a little bit lighter than the rest of them. Do you know the origin of the word Quaker in coffee?
Sorry, I laugh because it's something I researched, and then it's something that I asked a WhatsApp group today, and we had a bit of fun discussing it.
But there's no answer, right?
There's no answer. Yeah, but you can ask ChatGPT and get answers. And you can also, and the Reddit community has answers.
I saw the Reddit community's answers.
It's quite fun. ChatGPT is good as well.
What did ChatGPT tell us?
ChatGPT. One theory suggests that the term Quaker was coined because the pale color of the defective beans resembled the plain dress traditionally worn by members of the Religious Society of Friends, commonly known as Quakers. The analogy draws a parallel between the simplicity and plainness of Quaker attire and lack of development or browning in the coffee beans. Another theory proposes that the term may have originated from the Quaker Oats Company, which was well known in the early 20th century for its trademarked image of a Quaker man on its packaging. It's possible that the term Quaker was applied to pale coffee beans.
Yeah, if we went back and renamed it today or had the opportunity to do so, I suspect we wouldn't choose Quakers, given that the only occurrences of that word are related to religion, and all of the examples we came up with have some negative connotation. There's not really a place for that, I suspect. Now, perhaps there's another origin for this, but nonetheless, for the remainder of the podcast, we're going to use Quakers because it's the accepted term, but I suspect that it is soon to be an outdated term. But don't let that dissuade you from reading this article. It's a fabulous article. Congratulations to the students, postdocs, professors, and everybody who contributed to it. This is a really important topic that generally points to this idea: what level of defect should we tolerate in a coffee product and still be able to sell it or market it as a specialty product? Okay, so let's get into this real quick. The hypothesis of the article is basically that Quakers are not that bad, or we can't taste them at some certain level. So Andrew, I want to go to you first with a question. Is that you have the experience in this coffee industry, many, many, many years of experience. Can you tell me about whether Quakers are a problem? Have they been a problem for you? How do they manifest in the producing side? Do they show up in the cafes that you operated? Unpack the problem here.
Yeah, sure. First of all, I mean, as you're saying about this paper, it's a great paper, and it reads like a murder mystery of sorts. You know, where you're reading through the paper and you want to keep on going and solve the mystery before you get to the end. And so I was Yeah, I really enjoyed reading through this introduction and the methods and trying to work out if they'd done everything right, and if there was validity to what they were saying. Because yes, Quakers are an issue, and there's a few things in this paper which we'll probably get to. One is around the sensory panel, and they talk about Q graders in there. Okay, so just to clarify, what is a Q grader? A Q grader is someone who's certified to use the SCA 2004 score sheet to evaluate the sensory and physical qualities of a coffee. And it's generally deemed like it's considered to be one of the sort of higher quality certifications you can get in the coffee industry. I did it back in 2011. The tests for that for Quakers is there's basically a roasted, you do a whole series of tests, mostly focused on your sensory abilities. But there's also a green grading test, which is looking at the quality of the green coffee. And there's a roasted grading test. And that roasted grading test is very simple if you know what a Quaker is. You're literally given a sample of roasted coffee, and there's a Quaker in there, which is a pale bean.
Yeah.
And if you can pull out that Quaker and say this is a Quaker, you pass that test. So it's
I think I could pass that test.
Yeah, you would pass that test.
Yeah. So okay, but yeah, but these Q graders, right? So if they are trained to identify a Quaker, and by your suggestion then that most people would be able to identify a Quaker because it's something you can do with your eyes or perhaps a machine even, and they are thought to be negatively impacting the flavor profile. Is this something that like you would experience in a roastery where after you dump the roaster's load into the cooling tray, you would hand select them out? How many are we talking about here?
Yeah, look, it depends on the quality of coffee you're buying. And the processing of that coffee and the origin of that coffee. So Quakers are very common. So you'll often find a roaster, if they're hand roasting coffee, and it's not all an automated process where everything goes through is managed by silos and so on. But if you're hand roasting small batches of coffee, you'll often see the roaster drop a roast from the drum into the cooling tray, and then as the coffee's being cooled, it's basically spun around by these little there's like a fan which sucks the heat out and washes the coffee around. You'll see the roaster picking out beans that they don't like the look of. So they could be broken, chipped. There'll be some Quakers in there. They'll just quickly hand sort and throw them on the ground or throw them into a bin. Super common.
But even after I've done that, you're going to buy a bag of coffee, let's say, from a reputable roaster. You're going to assume they've done a pretty good job of sorting these things out, because of course, if they leave them in, they're making an active decision that they are going to negatively impact the flavor profile in principle, right? Yeah. But it's all about the number of those beans that starts to negatively impact the flavor. Yeah, but exactly. In your cafe, if you let's say you're loading up a hopper for your espresso machine, you're going to run through 5 kilos in a busy morning. Are you going to take the time to hand select out the additional ones, or are you just, if you see one and it happens to be on top, you'll get it and throw it away? Yeah, exactly. It's much more the latter, and that's where I think this paper is really valuable, because they are saying that the zero Quaker policy is about as realistic as a zero tolerance policy on drugs. I mean, it's never going to happen. There's going to be drugs,
and there's a level which is acceptable. I think what you're saying with, if you walk into a cafe and you see a Quaker in a hopper, should you just say, I'm not drinking coffee like that? That coffee is nowhere near the standard I should be drinking. The answer is pretty much no.
But just to clarify,
yeah.
But just to clarify, this is like you see people blend coffee regularly, and sometimes in the supermarket, and certainly in America, you can walk in, you can see someone who's taken a coffee to like Vienna roast, like super, super dark, and blend it with a much, much lighter coffee for some reason, which is a strange thing to do, but nonetheless, it does occur. We're not talking about that lighter coffee being a Quaker in that situation. This is within one origin, one bag, one roast that you've done. There's going to be some beans that come out a bit lighter, or sometimes very light, right?
And the reason they're not favored is because of the sensory quality and at the right concentration. So if you actually can take a whole bunch of Quakers out of a batch, grind them and taste that coffee will taste dry, it'll taste astringent, it'll have grassy notes, it'll have a peanut-like quality, kind of wheat-like. So maybe that's why it's called Quakers, because it's got that sort of oaty flavor to it, but it's very grassy, dry. It's not very pleasant. It doesn't have the sweetness, the acidity, or any of the quality and the attributes that you look for in a high quality coffee. So they definitely have a sensory impact, and you do want to. You can sensitize yourself to what a Quaker tastes like, and then you'll be much more discerning about which coffees you'll actually end up drinking.
So Andrew, they make the case in this paper that being able to tolerate some amount of Quakers is important to commercialize natural coffees as specialty. Can you comment on why this specifically impacts natural coffees more so than other processing methods?
Yeah, it's a good question. So fundamentally, the aim with processing of coffees. So coffee is a cherry. It grows on a tree. It looks like a cherry. It should be a ripe red fruit. Quakers in this case, they're not ripe enough. So they would have been slightly green when they were picked. They all got mixed in with the red ripe fruit, and that's where the Quakers come from. But there are different ways to process coffee, and processing is about removing the fruit from the seed, and the seed becomes the coffee bean, and it gets turned brown from green to brown, and you drink it and you know it as coffee. One of the ways to process coffee, which is a sustainable way to process coffee, but also a cheaper way to process coffee, is called the natural process. The natural process is where the fruit, so the skin and the underlying mucilage, is dried on the seed, and so it requires no water, but it misses out in large scale farming. It misses out one of the steps that's available in wash process coffees, where you can sort the coffee quality further. So basically, the coffee's picked and then it's laid out on patios and it's dried. Okay, so you miss out on this phase where you can float it in tanks. And if you see any coffee floating, it means that the density is light. It means it's underripe, or it's a stick or a leaf. And so that gets scraped off the top. And all the higher density, heavier cherries sink to the bottom. And then you get a natural kind of sorting process.
Yeah.
And that's common in washed coffees.
It seems like you can't detect the Quakers in the natural until after the roast. Well, that actually brings me to let's get into this paper a bit, okay? So what they did here is they basically sourced a naturally processed coffee from Brazil. They then roast this coffee, a sorted coffee, one that has had all the defects removed. They've roasted that coffee, and that's their control. They take that to an Agtron color of something like 53.7. In our lab, that is a quite dark roast. That's darker than sort of the conventional specialty coffee. But I think part of the reason they did that was because if you roast darker and darker, the Quakers become more and more obvious because they don't get dark, right? They stay pale. And then they have these other three color categories ranging from ever so slightly less dark than 53, all the way to something scoring a 95 on the Agtron scale, which is extremely light. That's basically yellow. And then what they're going to do in the paper is they're going to start mixing in these Quaker groups that are slightly, progressively more and more underdeveloped into the control. And they're going to then have the panel taste the coffee and say, at what point or concentration of this addition of Quakers is it starting to negatively impact the cup? Doran, remind me, what was the limit here for how many Quaker beans you could have in a given cup?
Yeah, so they determine that you start to negatively impact the cup only with the second group of Quaker beans. So the first group is just slightly lighter. The second group is significantly lighter. And for the second group, you can determine the presence of those Quakers by a sensory panel when you get to a presence of 7 beans per cup of 65 beans, which is over 10%.
A 10% Quaker concentration is a lot. You'd be hand selecting out a lot of coffee out of your roaster if you'd bought a batch that had 10%. Okay, so that's fine though. That methodology seems fine. You basically add it in, you get some people to taste. But Andrew, you mentioned that Q graders have to use a score sheet from the Specialty Coffee Association from 2004. Is that right?
Yes, yeah. The current SCA score sheet is 2004. However, a new system's being brought in. It's in beta and will be launched probably effectively next year.
Yeah, this is their new descriptive analysis.
Yeah, it's a descriptive analysis.
And effective, yeah.
Yeah.
But can you tell me then about the
yes, the
concern? Yeah, I think you have a concern with the way that the sensory panel evaluated these coffees.
One other thing I think it's worth calling out about the experimental design is the color groups. So there was color 1, color 2, and color 3. And color 1 was effectively dismissed. They couldn't find any difference from a sensory perspective. And it was 62.7, I think, on the Agtron scale.
10 clicks lighter. Yeah.
Yeah. So not significantly lighter. So it's not too surprising. But I think what's really valuable here is they're actually quantifying the color of a Quaker or the color of a bean that then has a sensory, impact. So
that's the first I've heard of anyone doing that, which is useful.
Yeah, it's really useful.
Just on that topic real quick, it does make you wonder, is it the difference? Is it the difference between the end or bulk color? Like, for example, this bulk is 53, and you can start to taste the Quaker problem when it's 7 beans in the cup at 83. So in other words, is it the fact there's a 30-point difference in the color between them? If I took a really light roast coffee that scored a 70, like a 75 on the Agtron scale, and it had some 83 Agtron colored Quakers in it, am I going to have a problem there? Or is it the fact that there's a big gap, or is there like an actual absolute color?
Yeah. So the Agtron reading is a blended average. And so it was an 8.25 gram sample or something, that's 65 beans. You grind the coffee to a grind size, and you measure the I guess it's refracted light. You can tell me more about that, to tell you what the color is of that blended sample of the ground coffee. And you can also measure either whole bean. In some color meters, you can measure whole bean, and you can measure ground. So
yeah.
It is the blended sample, and that's why when they roasted the controlled batch of, say, specialty and sorted coffee, they roasted that and they set the profile based on that one, because if they'd done it based on one which had the Quakers in it, then they wouldn't have been able to control the color and get it all to the same color at the end.
Right. Okay. But let me go back to the question I tried to ask you before, that there seems to be a problem with the sensory component here.
Yes, that's what's interesting. So this and I'm not a sensory scientist. I'm here from the coffee side, and I'm a lapsed Q grader. So I was a Q grader for 11 years, 12 years or something. But the Q grading is a defined protocol using the SCA score sheet, and you learn to judge green roasted coffee, and also the sensory characteristics of that coffee using that SCA score sheet and using a standardized sensory assessment protocol. And this sensory panel, in this case, they had 5 Q graders, okay? But the point here is that those Q graders, they're trained in using a specific sheet, a specific score sheet, but the actual score sheet they were using here was a different one. They were asked to assess things like astringency, and they were asked to assess intensity out of 10 for a range of different attributes and properties of the coffee. And that is not part of the SCA 2004 score sheet. So effectively, the sensory panel, which consisted of only 5 people, was untrained and uncalibrated on this sensory assessment protocol.
Yeah, so that means that you could, in principle, question the validity of the sensory result, although perhaps maybe we needn't worry about that so much, because the data more or less aligns with what the coffee industry also knows to be true, which is that Quakers impart astringency and bitterness, and this sensory panel also managed to detect that statistically significantly, I guess. So I guess that's okay. I mean, I always struggle with the sensory science side of things because it's when you're asking a human to do a chemical analysis with their nose or their tongue, you are inherently asking a human to do something that's very difficult. The fact that Q graders can, the Q graders can do this when they're, when they're qualified for within a parameter space is already impressive. Yeah, I look at this and I was convinced enough, but I understand your concern with it. It's, obviously there's always room for better sensory science, right?
Yeah, that's one of my questions, though. I mean, it's a journal of food chemistry.
Yeah.
And I always wonder, if you're publishing in the Journal of Food Chemistry, are you a chemist and not a sensory scientist? And, should you be mixing the two?
Well, should the two worlds meet? I don't, Doran. All right, let's talk to chemistry since we're at this point. Doran, there is some chemical analysis done in the paper, hence why it's published in the journal Food Chemistry. Tell us about what they did.
Yeah, so they're doing gas chromatography, mass spectrometry to back out which volatile compounds are in the coffee. And basically this involves heating up a sample and seeing what volatile compounds evolve from that sample and then measuring what their identity is. So they're able to measure for their control coffee and their 3 different batches of Quakers how the chemical composition, at least in the volatile space, evolves as you go lighter and lighter. And you'll notice that for some compounds, the concentration goes down as you go lighter. For some compounds, the concentration goes up as you go lighter. So when you roast coffee, you are destroying some compounds, right? They're getting broken down, maybe turned into CO2 and off-gassing. But other compounds are being formed. You can do Maillard reactions. You make new things as well. So it's difficult in the way that they assign it in this paper to say that this specific molecule is contributing to the effect that we're seeing because, like I said,
you mean flavor, right?
In the sense of flavor, because there are so many compounds. They're measuring 36 unique chemical compounds in this study. Because they're all changing in their populations in nonlinear ways, it's difficult to assign a sensory attribute to a specific molecule. But it is important to do the chemical analysis just to convince other people that, people that are maybe not in the coffee world, that the roasting process has an impact on the chemical composition, which therefore influences the sensory perception of the coffee.
So I'll give you an example. If you take a sugary compound and you dehydrate it, you can make 5-methylfurfural. So you would expect then to see that as a coffee is roasted darker, you generate more 5-methylfurfural. And indeed, that's true. The most light Quaker has the least amount of this compound. You can pick a different class of molecule, for example, methylpyrazine. The methylpyrazine must exist in the coffee before it's roasted because the lightest Quaker has the most of it. And as you roast to darker, you see less and less methylpyrazine. Your tongue tastes all of these things at once. It's not like you are sitting at the end of a gas chromatograph and just like drinking the coffee through the GC column. Although somebody should probably do that experiment. It'd be kind of weird. You're tasting it all at once. So when you taste a flavor of like astringency, it's not necessarily just one molecule increased enough that you taste it. It could also be that another family of molecules decreased enough that you're no longer able to hide that astringent flavor or whatever. We don't really know that. That's obviously one of the holy grails in food science, is to be able to understand this. But nonetheless, the chemical analysis more or less maps to what we would expect. There's some stuff is decreasing, some other stuff is increasing. Quakers have a different composition to that of the bulk roast coffee. Therefore, change the flavor when you put them in. And then the sensory panel, as you mentioned, Andrew, albeit maybe not exactly following a protocol you would typically expect to see in a conventional sensory study, they do identify that when you have a sufficient number of these Quakers in the bulk and you brew coffee with it, you're going to start tasting negative flavors associated with high concentrations of Quakers. The bulk conclusion of this paper then is pretty profound, I would say. It's one, as you correctly identified, Andrew, is that they've actually put a numerical value on the color that the Quaker has to be relative to a bulk for it to become termed a Quaker and have a negative sensory component to it. That's awesome. Number two, they identified this limit of 7 beans per 65 beans, or let's call it roughly 10%. 10% Quakers is a pretty high concentration, but I'll tell you what it's infinitely higher than: zero beans in the sample. So they're making the case in this paper that having a strict zero tolerance for Quakers, calling it specialty if it has none, even though at some point they don't actually negatively impact the taste, is probably a characterization or classification that we need to revisit.
So, Andrew, as the future president of the SCA, the very last paragraph of this paper says it's a direct address to the SCA, which says that the criteria should change. And how likely is that criteria to change in your view, both as a result of scientific papers like this one and also evolving ideas about coffee?
Look, it's 22 March in 2024 as we're recording this episode, and the green grading is being reviewed. We're actually in beta on that. And so this is super timely. I mean, this paper was published. It's published and can be taken into account. So it definitely should be. And I think, yeah, the standards are really important for many reasons. We haven't even talked about the color standards like Agtron and how valuable that is for consistency in your QC process in roasting. But look, from a green grading perspective, I think that this paper is strongly suggesting there is room for Quakers to be in a coffee. I think that there could be some more rigorous sensory assessment of Quakers in coffee, using this as a basis for further studies. So I think there's a lot of value in that. And it will instruct the green grading practices for the SCA. But I think, even zooming out a little bit further and applying this to industry, because I think it's important to make the science applicable to the wider world and the common practices of the coffee industry. And pretty much no one is having a zero tolerance on Quakers in coffee. It would be such a small number of roasters in the world who can afford to do this. By removing Quakers at any stage in the value chain, whether it's in the picking, processing, all the way through to roasting and sifting, and in a cafe, every time you remove Quaker, you're reducing the weight of the coffee, and you're increasing the cost. So if you're a roaster, you buy coffee, hopefully very clean without the Quakers in it, but you're going to get some. And then you insist on removing those, and you lose 5% or whatever your coffee. You're increasing the cost of that coffee by 5%. So that has a significant impact on the profitability of a cafe, of a roaster. Which will then get passed on to the cafe, which then gets passed on to the customer as well. So if there is a tolerance level, which is basically that there's no sensory, like if the Quakers are below a sensory threshold, and we can have that in there and it reduces the cost overall of the coffee to the consumer, then everyone is happy, I think. And that's why this research.
I do think that the membership of the SCA would think you're crazy if you go from 0 beans to 10% of beans.
Yeah. We gotta increment it in here. Yeah. So I think we've said it all on this paper. I have two final comments here. So in my journeys, and probably your journeys as well, Andrew, over the years, we occasionally find ourselves in front of cameras and we're doing coffee related things, like, for example, weighing beans or like making ourselves look like we're doing something. Okay. And I had this photo taken recently of some beans with some water added to them. They were looking nice and wet. Okay. And I had the opportunity to include a Quaker in that photo, but I elected to not, because it would make my photo look terrible. Because no one, and look, the best way to sort of normalize Quakers existing in specialty coffee is to start having them show up in place it in images and saying that's okay, but they look terrible. And they also don't taste good at high concentration. So, I'm still in my lab, I'm still not going to take a photo of a specialty coffee that has a Quaker sitting in there. Certainly not until the SCA tells me that that's still a specialty coffee. Cause I feel like we work in the specialty coffee market here. So, I don't want to make sure that, have one photo that invalidates our efforts.
What you're saying is science says it's okay, but Instagram says no.
Instagram says no. Yeah. And okay, now let me tell you one other story before we get out of here. So we do try in our lab to hand sort all the coffees that come into the lab and remove Quakers when we're individually weighing out all these coffees and putting them in the freezer. We go for 100-gram bags, which means at a time we have 100 grams in front of us. And so we are actually able to remove basically all of them from any sample that we ever get. So I guess we're probably unusual in that sense. I would like to collect them. So I had them in this like vacuum sealed bag that I was collecting, and I had a star on it saying this was like a special thing. And it was sitting in the top shelf of our freezer. And it was just going to be all the Quakers. And we were going to do the chemical analysis on it. And one day I wasn't in the lab, and I had this undergrad who was in the lab. And that particular day, the president of the university came by, and the undergrad wanted to serve them something really special. So they went to the freezer and they pulled out the bag that had the star on it, and they brewed this pour over, which was 100% Quakers. And I came in the lab the next day and I was like, hey, where's my Quaker bag? And the undergrad, who shall not be named, looked at me like, oh, I served that to the president. And I was like, oh, well, anyway, I guess we'll get back to collecting them again at some point. We're really grateful the paper was published. It provides lots of valuable insights, as have you, Andrew, as always, and Doran, of course. Thank you both very much for talking through this paper with me. Thank you all for listening. Tune in next time.